What's happening, everybody? Box Jellyfish here, and today I am back with another video. Today I am going to cover Jupiter's Great Red Spot, the largest storm in the solar system, which is much larger than the largest storms on Earth, mainly due to its being larger in diameter than the Earth itself. The Great Red Spot is a persistent high-pressure region in the atmosphere of Jupiter, producing an anticyclonic storm. An anticyclonic storm is simply a low-pressure storm. Located 22 degrees south of Jupiter's equator, it produces wind speeds up to 432 kilometers per hour. Observations from 1665 to 1713 are believed to be of the same storm. If this is correct, it has existed for at least 356 years. It was next observed in 1831, with 60 recorded observations between then and 1878, when continuous observations began. Jupiter's Great Red Spot rotates anti-clockwise, with a period of about 6 Earth days or 14 Jovian or Jupiter days, measuring 16,350 kilometers in width. As of 3rd of April 2017, Jupiter's Great Red Spot is 1.3 times the diameter of the Earth. The cloud tops of this storm are about 8 kilometers above the surrounding cloud tops. Infrared data have long indicated that the Great Red Spot is colder than most of the other clouds on the planet. The upper atmosphere above the storm, however, has substantially higher temperatures than the rest of the planet. Sound waves rising from the turbulence of the storm below have been proposed as an explanation for the heating of this region. Careful tracking of atmospheric features revealed the Great Red Spot's anti-clockwise circulation as far back as 1966, and these observations were dramatically confirmed by the Voyager flybys. The spot is confined by a modest eastward jet stream to its south and a very strong westward one to its north. Although winds around the edge of the spot peak at about 432 kilometers per hour, currents inside it seem stagnant. The rotation period of the spot has decreased with time, perhaps as a direct result of its steady reduction in size. The Great Red Spot's latitude has been stable for the duration of good observational records, typically varying by about a degree. Its longitude, however, is subject to constant variation. Because Jupiter does not rotate uniformly at all latitudes, astronomers have defined 3 different systems for defining the longitude. System 2 is used for latitudes of more than 10 degrees and was originally based on the average rotational period of the Great Red Spot, which is 9 hours, 55 minutes and 42 seconds. Despite this, however, the spot has lapped the planet in System 2 at least 10 times since the early 19th century. Its drift rate has changed dramatically over the years, and has been linked to the brightness of the south equatorial belt and the presence or absence of a south tropical disturbance. It is not known what causes the Great Red Spot's reddish colour. Hypotheses supported by laboratory experiments suppose that the colour may be caused by chemical products created from the solar ultraviolet irradiation of ammonium hydrosulfide and the organic compound acetylene, which produces a reddish material. Also, the high altitude of the compounds may contribute to the colouring of the Great Red Spot. The Great Red Spot varies greatly in hue, from almost brick red to pale salmon or even white. The spot occasionally disappears, becoming evident only through the red spot hollow, which is its location in the South Equatorial Belt, or SEB for short. Its visibility is apparently coupled to the SEB. When the belt is bright white, the spot tends to be dark, and when it is dark, the spot is usually light. These periods when the spot is dark or light occur at irregular intervals. From 1947 to 1997, the spot was darkest in the periods between 1961 and 1966, 1968 to 1975, 1989 to 1990, and 1992 to 1993. There is no definitive theory as to what causes the formation or colour of the Great Red Spot. Laboratory studies are examining the effects that cosmic rays or UV light from the Sun have on the chemical composition of the clouds of Jupiter. One question is whether the Sun's radiation reacts with ammonium hydrosulfide in the planet's outer atmosphere to create the deep red colour. Research suggests that the storm produces extreme amounts of gravity and sound waves, owing to the turbulence of the storm. The sound waves travel vertically upwards to a height of 800 kilometers above the storm, where they break in the upper atmosphere, converting wave energy into heat. This creates a region of upper atmosphere that is 1600 Kelvin or 1330 degrees Celsius, several hundred Kelvin warmer than the rest of the planet at this altitude. The reason that the storm has continued to exist for centuries is that there is no planetary surface to provide friction, only a liquid core of hydrogen. Also, circulating gas eddies persist for a very long time in the atmosphere because there is nothing to oppose their angular momentum. I hope you have enjoyed this video. Please like and subscribe as it really helps me out, and make sure to turn on notifications if you want to learn more about prehistoric life, space and science overall. Check out some of my other videos on this channel. Before I end this video, please subscribe to my new channel, Motorsports Explained, which the link will be down in the description below. And until next time, goodbye.